Yes, please could we have the intro music again, Tiernan? Hello and welcome to a live episode, live intros, outros for Lexx Education. It's the comedy science podcast where comedian me, mummy, Laura Lexx, hello child of the podcast, live in the audience. We are doing the intros, outros live from the Trifle Podcast Festival with a Halloween lab rat extravaganza.
Let's hear it from the normal people in the back over there.
I tell you what, I've been on tour, as obviously you guys know, because I've banged on about it so much, but it's really, so I was in Edinburgh this weekend, so I got to meet some of the more further afield lab rats, and the reaction from the rest of the audience when I can spot who listens to my podcast, and you can see them going, God, they don't have many listeners, do they? And I'm like, no, we've got loads, we just know each other really well, actually. It's that kind of a not a cult. Not a cult. That's it. You didn't all do it in time, though, so yeah.
Hello, I'm Ron, by the way.
Oh, yeah. Also, Ron's here. Hello, Ron.
Hello, normal brother Ron.
You've been looking after my child all weekend?
Yes, that's why I'm covered in food stains, even though these are the clothes that I tried to keep clean for the festival.
No, it's impossible.
Yeah.
Because her mouth
She
is
shit
always-
herself 6 times.
She hates
3
you.
times at a soft play.
See, I just let her just go pantsless and then it just falls to the bottom of the ball pool. Little parenting tip for you there that you won't see on the TikToks.
I wouldn't have minded that because then the clearly over 4-year-old children in the 0 to 4 area
Right?
would have got some shit on this.
Yes.
Yeah.
Last time I went to this particular one, which we won't shame on the podcast, but yeah, there's that under 4s bit. And there was this kid in there that was like, needed therapy. He had some violent tendencies. And the parents just kept like laughing, like, oh, he's a lot, isn't he? And then this other, like, one of the other mums was like, no, you need to sort him out. And they were just like, whatever. And then this other violent kid went in there and the rest of us were kind of like, now it's like a Thunderdome situation. Like, let's just leave these two. But then the dad of the second violent kid, like, lost his shit with his violent kid and removed him. And we were all like, no, we needed a bigger predator. Leave him in there. And it was horrible.
Yeah, I saw one of these preteens crying in the creche area. She was screaming, and then I saw her dad walk up a ramp, and then he just pointed at her and went, "Stop crying," and walked off.
Did you have flashbacks to our childhood?
Yeah.
Yeah. Did your own body just start sucking back in tears that you hadn't even shed yet? Like, no!
I was 2 hours into a soft play. I was already crying.
Oh, yeah. Did you have the cheesy chips there, though?
No.
Oh, they're really good.
Didn't eat anything there.
Oh, no, it's gross, but...
I saw how many times your child shit herself there, and I didn't fancy the food.
Oh, did you ask them about my knitting patterns? No, you didn't know. Never mind. One of the staff there, I was knitting one day, and it was dreadful because all the children kept coming on going, can I have a toy? And I was like, no, it takes ages, go away. And they were like, anyway. And but one of the staff came over and said she had a load of knitting books I could have. I've never got around to going back to them. Anyway.
So it's the second physics exam
today. It is the second physics exam today.
Have you guys listened to the first episode? Yeah! How do we think Laura did?
Thanks, Mike. The only one that had any sort of positivity. The problem that I've got now is that we've actually done one of the higher tier exams now. And knowing how that went, I'm like, I smashed the foundation. Like, I basically have a degree in physics compared to how the higher tier for biology. Don't look at me like that. I'm not saying I did really, really well, but compared to the higher tier...
No. But, like, you know that a degree is higher than higher tier GCSE, right?
No, but, like, I have a degree in foundation level biology, you know?
Yeah, you're good at foundation level biology.
Yeah, I have, like, a degree in it. It's just a... Shut up, Ron. Anyway, so you're going to get the second half of the exam today. Ron gets real sad in this episode.
I ate so much trifle.
The trifle really got to you, didn't it?
Yeah, well, I am allergic to cow's milk.
Why did you tell me to buy a trifle then?
I didn't.
You did. I said, shall I buy a trifle for you to eat during the show? And you said, I'll leave that up to your comedy judgment, and I thought it would be hilarious. And then you said you were sad about it.
Maybe it was a test of your comedy judgment.
Well, you tell me whether it's funny or not how sad Ron gets in this episode. So go listen to the episode. We'll see you afterwards. And then through the magic of editing, it'll be like...
The hydroelectric generator transfers electrical power of 3,000 watts to the village.
I don't know.
Calculate the energy transferred in 60 minutes.
So 3,000 watts to the village. So that would be the energy transferred. So I need to re-engineer this. So E equals power over time. Is that right? I'm dividing both sides by time. Yeah, power over time. So the power is 3,000, and then I'm dividing that by 60. So is that 50? Or has my maths abandoned me again? 3,000 divided by 60. Yeah, 50, Ron, is my answer.
50 joules.
Yeah.
3,000 watts.
Divided by 60 minutes. Wait, is
How long would it be if it was 120 minutes? How much power?
Huh?
How much energy transferred would there be if there was 120 minutes?
$25?
Yeah?
What are you getting at? Can you be clearer? I don't like this cryptivity.
So, the longer you do it, the less energy it transfers. Is that what you're telling me?
But, hang on. So, power equals energy transferred over time. So, in order to get energy on its own, I have to multiply it by time. Power times time. Hang on, Ron. Hold up. Don't worry, I figured it out by myself. I think it's 180,000, Ron.
Okay.
Maggie, do you need to go out? Do you need to go out, my little cooker bear?
What unit?
Jules, it says that on the sheet. Can you stop playing balls and... That's not even the same game that I'm playing.
It's the second one.
Whoa!
Yeah.
Ron, I really don't feel like you're trying very hard to make this podcast good.
Sorry.
I think you're playing balls and digesting trifle.
I'm so sluggish with trifle.
What's the opposite of trifle? Do you want...
Throw up?
No, don't throw up. Do you want...
Just leave me. Stop trying to problem solve.
Well, can you please do the podcast then?
Alright, 180,000, is it?
Is it?
That is wrong, but I'm not going to tell you why.
Oh, okay, go back to balls then. I've got more work to do. The hydroelectric generator transfers electrical power of 3,000 watts to the village. Okay, the watts is the power. So 3,000...
The equation wasn't wrong.
3,000 times 60?
The calculation's wrong, but the equation is right.
3,000 times 60, I get 180,000.
Yeah. The calculation is wrong.
Should time be in seconds?
Time should always be in the SI unit.
Oh, I don't know what that fucking is, do I?
Or is it likely to be minutes?
10,800,000 one?
2 marks.
Yes, I'm so close. Three?
Is it 3, is
Yeah,
it?
yeah.
3 marks. Always in SI units, always match the number of significant figures that the data you've been given is in.
What?
That's
What do you mean significant figures? What are you talking about?
The hydroelectric generator is turned by falling river water.
Beautiful.
Figure 5 shows how the power output of the hydroelectric generator varied during 1 year. It's high in the winter. That's what we must know.
Yeah. It's a deep ravine. Explain one reason why the power output varied. So, lower rainfall and therefore river levels in the summer months.
Say that again.
Lower rainfall and therefore river water levels cause less water to power the hydroelectric generator. Finished.
Final answer?
Yeah.
Page 20 now. Question 5. Oh, it's hot again. I really want loads of fresh air to be in here. Blow the trifle away.
Okay, hang on.
Yeah, that's good.
It's not going to sound good.
Just for question 5. Okay.
Don't put another biscuit in, Ron. The body doesn't know the difference between biscuits
Oh,
and...
look at this.
What's that circle in your biscuit? Is it like a little toffee in your biscuit? Oh, it's like biscuit archaeology.
Sugar of some kind.
Why? Your body doesn't know the difference between trifle sugar and biscuit sugar.
It does.
It doesn't.
It does.
It doesn't. This is the worst podcast ever made.
Why did we do this 3 days in a row?
Yeah, we thought...
My morale is through the floor.
Well, I think we should do something other than binge watch John Oliver at the end of this.
Let's go out.
Just leave Mackie like Nana in Peter Pan.
A student investigated how differing insulating materials affect the energy transfer from bottles of very hot water.
Very hot water. Okay, so
To
I've
prevent
got...
spillages, it's 4 bottles and they're at different temperatures.
And they've got different thickness of
insulating
insulation.
materials. They're labelled A to D. To prevent spillages, the student used a funnel to pour very hot water into each bottle. Why did the student use the funnel?
Well, okay, my options are preventing spillages was a control variable. To make the investigation valid, using the funnel was a safety precaution. I'd sort of argue all 3, really. The difficult thing is the diagram shows different levels of water. The text does not make clear. A student investigated how different insulating materials affect the energy transfer from bottles of very hot water. In order to make it a valid test, I'd have thought you needed to use the same amount of water, but the diagrams don't show that. So, I'm assuming they are leading to the funnel was a safety precaution then?
Final answer?
Yeah, I think so.
Oh, you were right about biscuit sugar. Why did the student not use insulation for bottle A?
Bottle A was the control. Oh, look at that. Most of page 21's blank, Ron.
Yeah, we're motoring through now.
22.
The student recorded how much the temperature of water in each bottle changed in 5 minutes. What equipment could the student use to measure time?
Is this a joke? A stopwatch?
You happy with that?
Yeah. That measures time. Oh my god, I'm even questioning that now. Yeah.
Okay.
Ron, don't say okay like that. That's fine, isn't it? A stopwatch.
Okay.
Yeah, I'm sure that came up yesterday. A burette?
What was that?
I just tapped my leg.
Don't do that.
Why? Are you jumpy?
Table 4. No, I'm fine actually. It's all an act. Table 4 shows the results. It's like the results Literally don't. Put it down. It shows the results. Figure 6 is repeated below.
What?
The student could
Ron,
not...
you can't just... Why are you glossing over the table?
Oh, sorry. A, none, 80, 60, 20. B, one layer of paper, 85, 70,
No,
15.
shafty little winch.
Nobody wants to hear that. Look, Laura, this is episode fucking 6 of these
Do you
exams.
reckon we're in the second half? We can't cut.
We've been doing this for an
I
hour.
think when the fan goes off, that's when we switch episodes, okay?
Okay.
I don't want people to start an episode with your fucking trifle fan blaring.
All right. What else do you want me to say about this table?
Well, listen, let's just look at it. It's...
Do it then. Do it if you're gonna
Okay,
do
don't
it.
do it then.
Do it then.
No, I don't want to anymore. You've made
It's
me
the
feel
results. It's
self-conscious.
got the insulation type, their start temperature, their final temperature, and the difference. They're all different numbers. The student could not make a valid conclusion from the results about how the different insulating materials affect the energy transfer. Explain 2 ways that the student could improve the investigation to be able to make a valid conclusion.
1. Use the same amount of water in each bottle.
Another exam tip, look at the number of marks that you're going to get for something. They've asked for 2 bits of info,
Yeah?
but you can score 4 marks.
Hang on, I haven't finished thinking.
Yeah, I know, I'm helping.
Yeah, I would use the same amount of water in each bottle, and I would have that water start at the same temperature.
Final answer?
No, I'm looking at the fucking diagram.
But you've given the 2 ways that they want. It says explain 2 ways.
Well, how can I say that in more language, though? Use this...
You've not explained. Read the question.
Okay, so... In this experiment, the student has used varied amounts of water in each bottle. This affects the energy retention of the water due to surface area and volume. So I would use the same amount of water in each bottle to make them the same.
Hang on. Because of surface area and what?
Volume.
Okay.
The student has also used different starting temperatures for the waters. Which would affect the rate of cooling, because cooling wouldn't necessarily be linear. So I would start them all at the same temperature to eliminate that complication.
Better.
4 big more.
There's a graph.
Ooh.
It looks like stairs where you can rest in the middle. But like stairs from a distance where you can rest in the middle. Non-paper card bubble wrap is at the bottom. Thanks.
I made you tea, Ron.
Thanks. Let's see if that
Melt all that trifle down into your
might be
butt.
anti-trifle.
I'm anti-trifle.
The student should not have plotted a line graph. What type of graph should the student have plotted? Give a reason for your answer.
I would... what would I plot? I would use a bar chart and I would show the temperature decrease information in that bar chart because you could then easily assess the size difference of the bars, would show you much more clearly which one had lost the most to the least.
Final answer?
Yeah.
Happy with that?
No. I don't really know how to explain what I mean. But it's not going on a journey. It's like static comparable bits of information, not a journey.
Yeah.
So that's why I'd use a bar chart.
Yeah.
Write that down?
Not what you said before.
Write that down then.
But you need to... Right, we're on to question 6 now, so this can go off. But
Mackie, in or out? I'm being so fucking smart and you keep interrupting it.
come on.
Did you write down my cleverness though?
You've not given me the cleverness.
did.
Yeah, you're on the zest of it, but you need to get real into the rind.
I don't know what the rind is. I would use a bar chart because the line graph is used to illustrate a journey of increase, decrease, or stasis, whereas a bar chart more clearly illustrates volume in different categories of results. So visually,
It's not about visually.
okay.
You...
Well, if it's not about visually, then don't fucking draw a graph, because a graph is a visual representation of your results. So it is about visually. It is, Ron. Otherwise, why are you doing a graph?
Why are you fighting with me? I'm
Because-
trying to help.
It's so frustrating when you represent science and science is wrong, but science isn't here.
There is a reason for it, and that is visual, but it's not about like, oh, it's because this is easier to read right now.
Well, then I don't know.
But you've said it, and I hope your description is enough.
Yeah, I don't care.
Why are you so sad now?
Because it's fucking thick behaviour.
From you or
No,
me?
by science.
Right.
Or not science, AQA.
Figure 8 shows a student before and during a bungee jump.
I love this
Why is it a
diagram.
student?
This diagram is not to scale.
It's got them standing on a bridge, a very small bridge with no
Looks like a
handrails.
slack line.
Yeah.
And there's nobody like standing there to help. He's not wearing a helmet. He's just got his feet tied up. There's no safety anything.
This is during the jump. It's above a river.
Okay. Oh yeah, there's the river.
In
Bridge,
position B, the student is moving towards the river and the bungee cord is stretching. How do the energy stores in position B compare with the energy stores in position A?
Okay, so position A is where he stood on the bridge.
Is the student's gravitational potential energy less, the same, or more than A?
The same.
Is the student's kinetic energy less, the same, or more than A?
More than A, because now he's moving.
Is the bungee cord's elastic potential energy less, the same, or more?
Less, because now it's stretched. Wait, no, because now it's stretched out and it's getting ready to ping back up. So actually, I think it's more.
Okay.
Because the cord wasn't doing any pulling, wasn't doing any energizing on the way down. The cord is the thing that energizes the way up. So it's more.
So you've got the same, more, and more.
Yeah. There's not less gravity. The gravity stays the same.
Read it again.
How do the energy stores in position B compare with the energy stores in position A? The student's gravitational potential energy. I think that would be the same. The student's kinetic energy in B is more because it's moving. The bungee cord's elastic potential energy is more.
Final answer?
Yeah.
The bungee cord behaves like a spring with a spring constant of 78.4 newtons per metre. At one point in the bungee jump, the extension of the bungee cord is 25 metres. Calculate the elastic potential energy stored by the bungee cord. Use the equation.
Okay, elastic potential energy equals 0.5 times the spring constant, which we've said is 78.4, times the extension squared. So that's 25 squared. I want you to stay. 25 squared is 625. Thank you. Flip it on your side. Get a scientific calculator. Phone. 0.5 times 78.4 times 25 squared equals 24,500 joules. Run along a ding dong.
Final answer?
Yep.
Table 5 shows information about bungee cords. It's 3 different bungee cords. They've got increasing spring constants and decreasing maximum extensions. That's how you describe a table. 6.3. Bungee cord C will have a smaller extension than A or B for any bungee jumper. Give the reason why.
Because the maximum extension of it snaps is 12 metres.
Final answer? Gonna have to press you. Final answer?
Yeah? Sure.
Which bungee cord would be safest to use for a person with a large weight?
I don't really know what spring constant means. C.
Give a reason for your answer.
Because it's got more new... wait, maybe I should work this out. I'm gonna just do some maths for a second and see what happens. So I'm going to multiply 78.4 times 36 equals 2822.4. Then I'm going to have a look at 82 times 24, 1968. Then I'm going to do 84.5 times 12 equals 1,000. I'm going to say the first one. It's bungee cord A, Ron, and I'm going to say because the spring constant across the extension gives the highest result.
Because the spring constant across the extension
Yeah.
gives the highest result.
Yeah. Maybe yield instead of result. Yield.
Highest yield.
Yeah.
Highest yield.
Yeah.
Okay. Question 7. Question 7.
Oh, God.
Laura.
Yeah.
Quasi Sevs.
I don't know how many questions there are, though, so it's hard to get excited.
10.
Oh, all right.
And page 39 is the last page of questions.
Ooh.
Yeah, there's
What are they
some-
doing for 5 pages at the end?
Well, there's one where it's like, don't write here, no questions here.
Ooh.
Wink, wink. And then there's a bunch of pages for nerds that need to write more.
Not me.
No, never been. Well, sometimes on the short ones, you're really like couscous poison, the poison for couscous. And then on the other ones, you're just like, well, fucking same amount of water and same temperature in it. 4 marks.
Have some more trifle.
You contain multitudes, don't, or I'll feed it to your dog.
No, not my little dog.
A teacher demonstrated the relationship between the
Feels like
pressure...
they've really all gone all out with the diagrams in physics. They've done a lot of drawings.
Also, why does it all have to be set at a school? Why did there have to be a student doing a bungee jump, and why is this a teacher?
Also, they've stopped telling us the
Can't it
little
be a woman for once?
question spoilers. You know, they're like, this question
yeah.
is about bungee jumping.
It does feel like different people have written them, and now that I say that out loud, I assume different people did.
I did a corporate for AQA a few months ago.
Yeah.
They were lovely people.
They should have got me in as well.
No. You'd have just
We could have-
stood there being awkward.
We could have done this in front of them.
Dissected their work. They take it really seriously. They're really, lovely.
Yeah, I'm sure they are. We love you, AQA.
Yeah.
You make us £80 a month.
No.
A teacher demonstrated the relationship between the pressure and the volume of a mixed mass of gas at constant temperature.
We're earning £1 an hour doing this.
It's bad, man.
It's really bad. Okay, a teacher demonstrated the relationship between the pressure and the volume of a fixed mass of gas.
Massive gas.
Pieces of fixed mass of gas at a constant
Love
temperature.
Massive Gas and their song Teardrop. That was a Massive Attack joke.
Yeah, I got it. Yeah,
Yeah.
I liked it.
I heard Banksy's in Massive Gas.
Yeah?
Yeah.
Huh.
There's another Massive Attack joke.
Oh, I didn't get that one.
People think Banksy's in Massive Attack.
Why?
Because I think like a lot of the early Banksys would be like where they were on tour, and like this kind of started in Bristol, which is where Massive Attack are from, and also like one of the guys in Massive Attack is like a painter.
Called John Banks.
No, Charlie Banks. C. Banks. Banksy.
Brian Anks. Brian Anksy. Banksy.
Complete the sentence. Particles in a gas move in
Random directions. That's right, isn't it?
Oh, it's trifle.
Can you
sickness.
please clearly say if it's me or the trifle that's making you despondent?
It's always both. Complete the sentence.
Whoa, most of page 29's nothing.
Particles in a gas move
Why have they
with.
left all of that empty? A constant speed. Probably. Can't see why they wouldn't. I'm going to say constant speed.
Table 6 shows some of the results. You got pressure in kilopascals on one side from 300 to 100.
Kilopascal. Sorry. I'm Pedro Pascal's daughter. Kilopascal. The hot new thing.
Did you know that they only call them that because of a mistranslation from the Spanish? 400 years ago they were called Pascal killers.
I don't think anybody laughed at that.
Oh, sorry, I should have just said it louder but in a silly voice.
Yeah.
I made a funny joke about interactions with Spanish whalers.
Whalers?
Whalers?
What's it got to do with whalers?
Killer whales?
Oh, I thought you were just doing like a Cortez bit. Like,
No, that's why they're called killer whales.
oh. It was not clear.
My crowd would have got that.
Trifle?
I will throw that at the wall.
You've hardly eaten any of the straw bit, though.
You eat it if you want
it's
it.
taking ages to drip off the spoon.
Yeah, it's compote. Laura, stop playing with the
For
trifle.
two people that desperately want this to be over, we are fucking about quite a lot.
We?
Yeah. I've got no question to answer, buddy. What do you want me to do?
That's because you keep... Oh, you didn't get my really funny joke about killer whales.
I didn't know that it was whale orientated.
You love orcas. I thought you'd get
talking
it.
about Spaniards, so I started thinking about like Road to El Dorado and stuff.
Yeah, that's because you've never progressed away from Disney.
I have, but it's a good film. I think that's Kevin Kline
Okay.
and Kenneth Branagh.
And Kevin Branagh. Who's Kevin Kline? Why have you said that like we've talked about him recently?
No, we've talked about Kenneth Branagh.
Yeah, that's not what you said.
No, he's in it too with Kevin Kline. Kevin Kline is the one in As Good as It Gets.
Have I seen that?
Have you not? Feels like a film you would love because it's so weird.
Jack Nicholson. I've never seen a film with Jack Nicholson in it.
Really?
There's a guy called Skeet Ulrich in that film.
Yeah, Skeet.
Ah, Maya Rudolph. She plays a
She's in
policewoman. Yeah.
Huh.
She's older than you'd think.
Yeah, clearly, because I remember that film since the beginning of time.
She plays a policewoman as well, so she was a grown-up.
Whoa.
Well, she's 52.
Whoa!
She's a funny lady.
She's very funny.
The
She's
wo-
playing Kamala Harris in the SNL sketches, isn't she?
I don't know, but that scans. She's from Florida.
She's Minnie Riperton's daughter.
I knew she was a Nepo baby, but I don't know who Minnie Riperton is.
Loving you is easy 'cause you're beautiful.
You'll never guess.
Didn't.
This is the sort of thing that infects my brain, and I will think about this every year until I die. But Minnie Riperton's birthday's the day before mine. And I will never forget that. Well, Minnie Riperton died in 1979, though.
Whoa, Maya must have been young.
Yeah, she was only 7 or 8, depending on when it happened in the year. Oh, it was 2 weeks before her 7th birthday.
Ugh, I hate that for her.
That's really sad.
Made her very funny, though, dealing with that tragedy. I bet people say to her all the time, and then she feels like, no, I'd have been funny anyway, and I'd rather have kept my mum.
Richard Rudolph was her dad. What songs did he write?
Me, the red-nosed reindeer. Look at my shiny nose.
He wrote a song for John Leguizamo
In Moulin Rouge?
called The Pest, brackets Voodoo Mambo.
Oh.
Let's have a bit of The Pest, brackets Voodoo Mambo before we carry on.
Ron, we should carry on. Carry on, carry on. Nothing really matters. Remember to edit this out. Ooh.
It's a long walk.
Giddy! Had to change my t-shirt. Spilt curry on it. Ron's eating trifle. He's sick now. Oh, this is not favourable to your hairline, this look. Look, lean forward again.
You must keep going.
It's you're the one that's talking about fucking Rudolphs.
Yeah, you gotta talk about Maya Rudolph when she comes up.
Maya Rudolph.
My sugar high is not here.
Have some more trifle.
No, can we please carry on?
Yeah, do it.
No. Right. The first point. Oh, we can't do graphs, so we can skip that one. Laura?
We need to be less excited about all the content we can skip and more excited about the content we are doing. Ron.
7.4.
Whoa!
God, we're an hour 20 in. Come on. Focus up.
Yeah.
The relationship between the pressure and the volume of gas is given by the equation. Calculate the constant when the pressure of the gas was 300 kilopascals.
Everyone hates you.
I don't think you can do that. No, you can. That's fine. Carry on.
Pressure times volume equals constant. The constant is what we're trying to work out. The pressure of the gas was 300 kilopascals. The volume. Do we know the volume? Table 6 shows some of the results. Plot the points from table 6, draw the line of best fit. That bit we're not doing. The relationship between the pressure and the volume of gas is given by the equation pressure times volume equals constant. Calculate the constant when the pressure of the gas was 300. Oh, okay, so that means the volume is 10 centimetres cubed isn't the SI unit? Would be millimetres cubed? Centimetres cubed? I think metres is the SI unit, weirdly, isn't it?
What unit do you need to give your answer in?
Centimetres cubed. Alright, let's just leave it alone then. 10. Oh, Christ. Yeah, okay, so let's just do 300 times 10. 3,000. 3,000 kilopascal centimetres cubed.
Whoa. Sorry. Alright. Oh, I'm really trifle crashing. When the volume of the gas increases, Laura, the pressure of the gas decreases. The temperature of the gas stays the same. How does increasing the volume affect each of the following? Mean time between collisions of the particles within the tube. Decrease, stay the same, increase. You'll never guess what the plot of The Pest is.
That would decrease, I think, because they would collide more often if you increase the volume of gas. Because there's more gas particles.
Say that again.
Well, if you're increasing the volume of gas within the same space, is it within the same space?
What does volume mean?
Well,
Technical gremlins, guys.
Technical fucking gremlins.
Okay, yes, the volume of the gas increases, right. The volume of the gas has increased, Laura.
Yeah.
Just because your help happened off mic now does not mean you did not still get it. No, it's
Okay,
still gone.
so we decided that.
Mean time between collisions of the particles within the tube.
Increases.
Okay, mean distance between particles.
Increases.
And mean speed of the particles.
Stays the same.
And now we're on to the national grid.
Oh God! So we've already done all of this. We'll redo it, just summarising, because technical gremlins have switched the fucking microphone off. Just the worst bit as well.
I don't know why this is happening today. It didn't happen when we recorded chemistry at all.
Because it knows that I hate physics.
Do you want a biscuit?
No.
Yeah, I feel sick. I feel sick to my stomach.
Just cross. Right, we've got a lovely national grid. We had some good japes about that. Right, it's two transformers. So the first transformer on causes the potential difference to...
Oh.
What?
You know that there are two transformers, but only one of them's labelled X.
Oh, yeah. Transform X causes the potential difference to... I don't know, increase and then decrease. I don't know.
Okay,
I hate this section.
Swamped what you said before.
I don't know, Ron. Right, this next one, the answer was P equals I squared R.
The people don't care. We'll move on. That's fine.
Listen, Ron.
The next one, I've just written wrong in block capitals because you were so wrong.
Fine. Just don't even care anymore. The equation which links efficiency, total energy input, and useful energy output, efficiency equals useful power output over total power input.
Yeah, and then we were doing
know.
this one.
Yeah, what did I come up with here? The total gigajoules.
Yeah, we've got that down as 3 point... We've kind of done the worst of both worlds here, haven't we? We've gone through it, but not...
Listen, it was horrible, hateful, heated garbage.
Okay, right.
Question 9.
Question 9. We did it. Another lovely diagram.
Yeah. Got a power supply. It's plugged into a joule meter. It's not showing a 0 error on. That's plugged into a heater in an iron block with a thermometer, and there's a stop clock next to it.
Oh, you wrote stopwatch before, hopefully.
Oh, stopwatch is fine.
The iron block. Figure 12 shows the equipment a student used to determine the specific heat capacity of iron. The iron block the student used has 2 holes, one for the heater and one for the thermometer. Before the power supply was switched on, the thermometer was used to measure the temperature of the iron block. The student left the thermometer in the iron block for a few minutes before recording the temperature. Suggest why for 1 mark.
To make sure the thermometer adjusted to the temperature of the iron block from the temperature of the air. Finished.
Couscous. Poison.
That was all right.
Yeah, I'm
I'm
just
going to start flinging Trifle at you in a
Yeah,
minute.
you're cross. He's...
I hate this so
Can't
much.
you wait to do higher tier?
I'm not doing it.
Figure 13, unlucky for some, shows how the temperature changed after the power supply was switched on. It's like a hockey stick.
Yeah.
Time in minutes goes up, and so does temperature. Mm-hmm. The energy transferred to the iron block between 5 and 10 minutes was 26,000 joules. The mass of the iron block was 2 kilograms. Calculate the specific heat capacity of iron.
Okay.
Okay.
Okay, so... oh, Christ. Breaks my fucking brain. So, the change in temperature was... It's gone from 28 to 54. 28 to 54, that's 26 degrees C increase. Okay. And the mass is 2 kilograms. Okay. And the change in thermal energy, 26,000 joules, I guess. Okay. Okay. Then, so specific heat capacity. So it's 26,000 over 56, I think. Oh, Christ. 26,000 divided by 56. It doesn't feel like it's going to be right. But Ron, I'm going to go with 464.3 joules per kilogram.
Say it again.
464.3 joules per kilogram. Degrees C.
Okay. The student repeated the investigation but wrapped insulation around the iron block. What effect would adding insulation have had on this investigation?
Right, I've got to tick 2 boxes here. So, the calculated specific heat capacity would be more accurate? No. The iron block will transfer thermal energy to the surroundings at a lower rate? Yes, tick that one. The power output of the heater will be lower than expected? The temperature of the iron block will increase more slowly than expected? No. The uncertainty in the temperature measurement will be greater. The uncertainty in the temperature measurement will be greater. Let's go with the first one. The calculated specific heat capacity will be more accurate.
Laura.
Yeah.
Question 10, last question.
Oh my God.
We get to stop. We get to stop. Figure 14, Laura, shows an electrical circuit used to heat the windscreen of a car.
I'd love one of these.
Each resistor in the circuit represents a heating element. The 12-volt battery... Why wouldn't you use the car battery? Maybe they've got 12 volts. The 12-volt battery supplies direct potential difference. What is meant by direct potential difference?
Energy. Voltage. Voltage. Voltage, Ron. Voltage. Just write voltage once. Don't write voltage, 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 Ron, voltage. Okay? Voltage, 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 Ron, voltage. It's a dance hit from the 90s.
Use the equation sheet, Laura. Which equation links flow, energy, and potential difference?
I'm looking for Q, E, and V on my sheet. Oh, E equals Q times V. E equals QV.
Calculate the charge flow through the battery when the battery transfers 5,010 joules of energy.
Ooh. Okay. 5,010 joules and 12 volts. What did I say? E equals QV. So that's that one would equal that times that. So to get that answer, I've got to multiply it by that. So I've got to multiply that one by that. So that is 510 times 12 equals 60,120, Ron.
Okay.
No, wait. I gotta divide. I keep getting that. 417.5, Ron.
Okay. Question 4. Ice forms on the windscreen at a temperature of 0 degrees. The electrical circuit transfers 5,010 joules of energy to the ice. A mass of 0.015 kilograms of ice melts. What's the specific latent heat of fusion of water? Oh, God.
Right, the mass was 0.015 kilograms times me question mark, and the thermal energy for a change of state, so I guess that's 510 joules equals, so to get the specific latent heat on its own, I got to divide that by that. Divided by 5010 divided by 0.015 equals, doesn't feel good, 334,000 joules per kilogram.
330,000.
Nope, 334,000 joules per kg.
Okay. Oh, I think it's the last question. It's the last question for 6 marks. The electrical circuit was left switched on while the ice changed from solid to a liquid and increased in temperature to 5 degrees. Explain the changes in the arrangement and movement of the particles as the ice melted and the temperature increased to 5 degrees.
Okay, so when the water is in solid form as ice, the particles have low energy and a rigid arrangement with little to no movement and strong bonds between one another. As the energy increases, the particles gain energy, their movement intensity and speed increases, causing the arrangement to be more erratic with much looser bonds between the particles. Which is a liquid form.
You want to read about it?
No.
We're done. Can we go? Can we stop? Can
We
please
did it
stop?
wrong.
Oh,
We did it wrong.
now just higher tier.
No. Horrible idea. Do you not feel like we need to do some revision before we do higher tier on?
Well, we'll mark these. That's a form of revision.
Yeah, I guess so.
Yeah. Maybe we don't do those in one recording block, though.
Yeah.
Yeah. All right. See you for the quiz.
No. This was the quiz.
Cool, quiz, baby. All right.
I've driven from Carlisle this morning. I'm so tired. I didn't know that there was a storm. There's a storm. I think I drove through all of a storm today. Anyway.
Sorry, Carol, why are you on your phone, mate?
Bingo.
Not allowed on your phone during class?
That is dedication.
Who's looking after child of the podcast?
A lady who shall not be mentioned. Never met her before, actually. She just came into the pub and looked trustworthy, and I was like, do you know what? Have a child of the podcast.
Thank you.
Oh, God, they've planned things. Oh, God. So, yeah, that was the end of the physics episode. You're going to have to wait an extra week for the physics results because next week is Halloween special. So obviously, right now we're recording some live intros, outros, live from the Cheerful Airport podcast where we are just about to record a patrons-only episode all about werewolves, but that is only for the best listeners. For all you basic bitches, we've got a boring... Actually, I really like next week's episode. It's about spiders. Halloween. And I think it's the giddiest we've
Room
been in a
episode,
while.
and I think it starts raining right at the
It
end.
does. And I do so many songs about cum thumbs. Remember that bit?
Yeah, the cum thumb.
Yeah. It'll all make so much sense next week. Yeah, I sang that in front of my child. Whatever.
You say cum thumb?
No. So, should we do a register?
Okay, cool. Right, ready? Thank you very much.
We all just stopped partway through there, didn't we? We started it and then it ended. We want to say thank you to Kay, who we are employing as the official Lexx Education A-level professionalism ombudsman, a relatively toothless bureaucrat who either Laura or Ron can submit claims into if the other is not being professional enough. They are mainly in charge of removing all food and drink, other than Ron, including Ron's water, from the studio. Thank you, Kay!
Thank you, Kay!
And a quick note about Kay, actually. Kay was in the front row of my tour show in Edinburgh on Friday, sitting next to Neil, Scottish representative of the lab rat community. And I mistook him. I thought he was a patron, because I think I just chat to him on Twitter sometimes, so he'd signed up by the interval, which I think is good dedication and emotional blackmail from me. So we should put that on the spreadsheet of physically eye to eye with somebody and accusing them of supporting you when they don't, and then they feel too guilty.
That's
to
a good point. Who here isn't a patron? What did you do last night?
Oh, what did I do? Just be like, oh, hey, oh, you're a patron? Oh, no, you don't contribute to keeping this adorable little girl alive? Oh, I was, just for people listening, I was pointing to Child of the Podcast, not me. I'm not like, I'm an adorable little girl. So, done, yes! So, what
I
I'll
think
do is I'll
last
give
thing
out
that
my
we could do that
address.
could be fun.
What?
Last thing that we could do that could be fun. Do you guys want to choose the episode title for this episode? Okay. Do we like what's the opposite of trifle? You're playing balls. Blow the trifle away. A theme emerging. Trifle fan blaring. Quasi Sevs. Me, the red-nosed reindeer, or total giggle jewels? What do we like? Do we like what's the
Okay,
opposite of
but-
trifle? Rhetorical question. Blow the trifle away. Okay, let's have one cheer for what's the opposite of trifle? Let's have another cheer for blow the trifle away.
Blow the trifle away. All right,
Thanks,
I will
guys.
edit that tonight when I get home and you guys have chosen it. So thank you for listening. No, okay, that was a part of the podcast issue. Are you okay? Oh, nice. A lipstick. Thank you for listening. Thank you for coming. We're going to get werewolfy now. You guys just listening can go about your mornings or whatnot. And we'll see you next week with a Halloween episode.
Woo! Class dismissed. Outro.
Pencils down.
Pencils down.
But you could still do it spooky if
Pencils down.
Yeah, perfect. Perfect. No notes. What are you doing?
Could we have the outro music?
Hey! You look beautiful, darling.